if a parabola never touches the x-axis, it has what is called complex or imaginary roots. When calculating the roots of such a function, a negative number appears under the radical. So complex or imaginary roots is when a parabola that's being graphed never touches the x-axis. It doesn't have roots. So we call them imaginary roots. So we can use the symbol I to show that they are imaginary when we're solving using the quadratic equation. So -1 under our radical gets replaced with I because I squared equals -1. So if you take a look at my calculator, I'm showing you and proving to you why this happens. If you take the square root of -16, it gives you that there's an error because it's a non-real answer. If you recall, when you take the square root, you're supposed to get a number times itself. But if you have a negative number, you cannot find such a number times exactly itself. -16 would be -4 times 4. So therefore, it cannot be taken the square root of. So to show that, you would use 4i as the answer of the square root of -16. So square root -16 is expressed as 4i. Square root -25 is expressed as 5i. Similarly, square root of -8 would be the square root of -4 times 2. So that would be written as 2i square root 2. So we're going to use that idea to look at some functions and find their imaginary roots. So for number 1, I'm going to prove to you first that it has imaginary roots. If we go back to our calculator and type in the equation for number 1, we have x squared minus 6x plus 25. We pull up the graph, not second, just graph. And you can see on my graph, nothing appears. But if we go to zoom and go down to number 3, press enter and enter again, the graph is zoomed out and we have our parabola that never touches the x-axis. So when we go to solve this, we're going to have I in our answer for the roots because there are imaginary roots in this case, non-real imaginary roots. So taking a look at number 1 again, we're going to plug it into the equation the same way we did yesterday. So we have x equals negative b, which is -6, so that's going to be +6 plus or minus the square root of -6 squared is 36 minus 4 times 1, which is a, times 25, which is c, all over 2 times 1, which is just 2. We go further, x now equals 6 plus or minus the square root of 36 minus 4 times 1 is 4, times 25 is 100, all over 2. Simplifying again, x equals 6 plus or minus the square root of -64 all over 2. Now, we know the square root of 64 is 8, so the square root of -64 is 8i. X equals 6 plus or minus 8i over 2. And our last step is just to simplify, as everything in the numerator is divisible by 2. So we get x equals 3 plus or minus 4i. Now, one term has an I, one term does not, so we cannot put them together. That's as simple as it gets. And because we have an I, we know we have non-real imaginary roots. Number 2, we do the same way. X equals negative b is going to be +10 plus or minus the square root of b squared is -10 squared, which is 100, minus 4 times 1 times 29, all over 2a, which is 2, because it's 2 times 1, equals 10 plus or minus the square root of 100 minus 4 times 1 is 4 times 29 is 116, all over 2. So x equals 10 plus or minus the square root of -16 all over 2. So we know that the square root of 16 is 4, so the square root of negative 16 is 4i. 10 plus or minus 4i over 2. And just like before, since both the 10 and 4 are divisible by 2, we can simplify it one more step. 10 equals 5 plus or minus 2i, and that's as far as we can go. Again, proving that this has imaginary non-real roots. Okay, so let's continue with 2 more examples. Make sure we've really got this process down. For number 3, we're going to modify the equation a little bit. Let's change the negative x to negative 6x, please. And then we're going to go on with the process. So x equals negative b, so that's going to be positive 6 in this case, since it's negative 6 in the equation, because the negative and negative make a positive, plus or minus the square root of negative 6 squared is 36, minus 4 times 4, because that's the a value, times 7, because that's the c value, all over 2 times 4, which is 8. Going further, 6 plus or minus the square root of 36 minus 4 times 4 is 16, and 16 times 7 gives me 112, all over 8. Further simplifying, 6 plus or minus the square root of 36 minus 112, which is negative 76, all over 8. Going further, 76 has a factor of 4, which is a perfect square. If we do negative 76 divided by 4 in our calculator, we get negative 19. So we have 6 plus or minus. The negative 76 is like doing negative 4 times positive 19. I'm going to use the negative 4 to make that be our I. Square root of negative 4 is going to be 2i, leaving the 19 under the radical because I cannot take its square root, all over 8. And from here, I can simplify it one more step because both the 6 and 2 and 8 are, or all 3 rather, are even numbers. So I'm going to go ahead and simplify each part of that. So 6 and 8 become 3 and 4, 2 becomes 1. So 3 plus or minus I times radical 19, because I'm dividing everything by 2, all over 4 is my simplified answer. And that's as far as I can go. I cannot combine any like terms. I can't divide 3/4 or 1/4. You want to leave it as one compressed answer. So again, we know we have imaginary non-real roots because the I is in our answer. Okay, so one more time together, we have x equals negative b, which would be negative 1 in this case, plus or minus the square root of 1 squared is 1 minus 4 times 2 times 1, all over 2a, which is going to be 2 times 2, or 4. Simplify further, negative 1 plus or minus the square root of 1 minus 4 times 2 times 1 is just 8, all over 4. X then equals negative 1 plus or minus the square root of negative 7 over 4. So x equals negative 1 plus or minus I radical 7 over 4. I took the negative 1 out. Negative 1 times 7 is 7. Square root of negative 1 is I. And that's as simplified as it gets because 1 and 1 aren't going to be divisible by 4, resulting in a whole number. And so we cannot simplify it any further. Again, I is in our answer, so these are non-real imaginary roots. So the graph of 2x squared plus x plus 1 would not cross the x-axis at all. There would not be any roots. You're going to try the next 4 on your own, answering the questions as you go. Be sure to ask me questions if you need any help.